Okay, so our project is on alkanes, alkenes, and alkynes, and I'll start off with the physical characteristics. Alkynes can exist as solids, liquids, or gases at room temperature. Alkanes that are branched generally have lower boiling points than unbranched ones. This is because of the greater van der Waals forces between unbranched alkanes. Alkanes can also be dipole-dipole. Solid alkanes are generally soft with lower melting points. This is because of the strong repulsion between the electrons, since they're also close together. These repulsions actually counteract the van der Waals forces. Alkanes are pretty much almost insoluble in water. To actually be soluble, the van der Waals forces have to be stronger than dipole-dipole forces, but this isn't the case. Alkenes are very similar to alkanes, except for the double bond that exists between them. They usually can exist in the same states at room temperature. Isomers of cis-alkanes have lower melting points than trans-alkanes. Cis-alkanes or alkenes have the two carbons or two hydrogens on the top there, as you can see, and trans-alkenes have diagonal hydrogens, as you can see there. Isomeric alkenes tend to have similar boiling points, so it's different to distinguish them by boiling point differences. And alkynes are generally nonpolar. 4 or less carbon atoms in alkynes mean they are usually gases. Alkynes are insoluble in water, and they have nearly the same boiling point as alkanes and alkenes with the same carbon skeleton. Okay, so for structural characteristics, alkanes are organic compounds of hydrocarbons where all carbon-carbon bonds are single bonds. These are saturated because all the carbons are bonded to either another carbon atom or just hydrogens. All of the carbon-hydrogen bonds are sigma bonds, and each carbon is the center of a tetrahedral structure. So, like right there, you can see the drawing there. That's a tetrahedral structure of an alkane. All the bond angles in an alkane are close to 109 degrees. Alkenes are hydrocarbon with at least one carbon-carbon double bond. These are unsaturated because, as you can see from the drawings below, the double bonds cause the carbon to take up one less hydrogen bond. These double bonds can be in different places, and this forms stereoisomers. So as you can see by the two different drawings there, the two double bonds in the separate locations cause the structure to be different. Even though there's the same amount of carbons and hydrogens, they're still different. And alkynes, these are hydrocarbons with at least one triple bond, and the triple bonds can also be found in different places. There are no stereoisomers. This is because of the bonding in the triple bonds are all sp hybridized. Okay, chemical characteristics of alkanes, alkenes, and alkynes. Alkanes are usually stable at room temperature towards reactants like concentrated acids or bases. When heated at high temperatures, they can break down into smaller molecules. Since the single bonds are so strong, they tend to react poorly with ionic or other polar substances. All alkanes can react with oxygen in a combustion reaction. Usually with more carbon atoms, it becomes harder to react with oxygen. And alkenes. In the alkenes, one of the double bonds can be attacked and become a single bond by a reagent. And this causes it to become saturated and also becomes a alkane. or can become an alkane. Alkanes are readily reduced by addition of hydrogens across double bonds to form alkanes. Alkenes are highly flammable and combust with oxygen. The most important alkene reactions occur across the double bonds, and hydration reactions can occur with alkenes to form alcohols. Okay. Alkynes. These are generally more unsaturated than alkenes because they have triple bonds in them. They're more reactive than alkenes and show a greater tendency to polymerize. Alkynes are also sp hybridized and linear. These are generally more acidic than alkanes and alkenes, and these are also high in energy because of the repulsion between the electrons.